this video is going to wrap up this sort of crypto Ghoulz project that I've got. And the project is in 4 parts, I guess, now. So we've got this website, we've got a selection of blog posts, and we've got our boilerplate. And now we've got this video, which is, going to go through the code and all that sort of stuff, and hopefully make it a lot clearer for anyone that wants to do some blockchain work. So, let's go through it. So, what is Crypto Ghoulz? So, Crypto Ghoulz is a blockchain project that I built using React, IPFS, Truffle, Web3.js and Solidity. And don't worry if you've never heard of any of those things. I'm going to go through it when we do the sort of code walkthrough of the boilerplate. So don't worry at all. So this project, it's specifically an NFT project where I generated 1,000 random NFT trading cards with different stats, names, ratings and imagery. A user can navigate the website and purchase an NFT. And at first this was going to be on the Ethereum mainnet, but it costs so much to mint the tokens. It was going to cost me £3,000, which is a lot when it's just some sort of pet project that I wasn't going to really push to be anything. And so instead I put the contracts on the Polygon mainnet and I minted all of the NFTs for 30 pence, and that is like 1,000 times cheaper than on the Ethereum mainnet. So for this sort of project, that's fine. I guess if you were doing something that you're putting your heart and soul into, then, and it's going to be your actual business, then maybe you would want to spend that money and get it on the Ethereum mainnet. It's probably cheaper now anyway. But anyway, moving on. So then we've got this short collection of blog posts. It's just 3. And as I was creating the Crypto Ghoulz project, I was documenting it down, and then that turned into a variety of blog posts. And the posts don't go into detail about how I generated the artwork for the NFTs, but what it does is it gives an insight into how to get started with the sort of front-end JavaScript code and sort of the blockchain Solidity sort of code, and also combining the two using Web3.js. So I created the blog post explaining how a developer could create a React project, deploy a Solidity ERC 721 NFT contract, and mint some NFTs. The blog posts go through the process from start to finish, but are completely stripped back from any of the user interface or branding of Crypto Ghoulz. They're pretty much separate, but in honesty, it's the underlying stuff that I used for Crypto Ghoulz, so that's why I sort of joined the two together to show you what sort of project you could make. But yeah, I thought it was important that the boilerplate is very stripped back, almost white labeled to nothing, and just has the sort of the underlying code there, so anyone can grab it and get started and go in any direction they want, and they're not stuck on this jazzy madness that I've got here. So why is there a video? So as I mentioned at the beginning, the video is the final bit that's going to tie everything up and hopefully help a lot of people get started in this sort of space. And the information is out there, and there's a lot of great videos and blog posts, but it is quite hard at first to get your head around it. So hopefully this will make it seem really simple and you can jump straight in. So the tech used, so we have what you would call Web 2 and Web 3, and for Web 2, that is just sort of the internet, or the websites that we know and love at the moment. So it's all the websites out there, Facebook, Amazon, all of that stuff is Web 2, and you can use any JavaScript framework for the front end for this sort of project. So I used React for Crypto Ghoulz, as that was just the one I'm just currently most familiar with. But in reality, it could have been a vanilla JavaScript app. And the front end, outside of the design, it's just a vehicle to allow the user to connect their wallet to your website and purchase an NFT. And all of that is facilitated by Web3.js. Now, the boilerplate uses React, but it's very, very bare bones and simplistic. I'm going to completely skip over setting up React, and instead I'm just going to focus on getting the guts of the project going. So we'll get into that soon. Now, Web3.js allows us to connect to the smart contract from the front end, and it allows us to call methods on the Solidity contracts, such as mint, or get the ownership of a token, or how many NFTs have been minted, and all this sort of stuff. It essentially makes our browser a blockchain browser. Solidity is the language that is used to write the smart contracts, and Truffle is used to compile and deploy the smart contracts. There are alternatives to Web3.js and Truffle. An alternative for Web3.js is something called Ethers, which is very popular at the moment, and an alternative for Truffle is something called Hardhat, which is, excellent also. But in this, it's Web3.js, Truffle, and Solidity. Right, so let's get into the actual code of the boilerplate, right? So the best place to start is our env file. And what we've got is we've got an example env, which is included in the boilerplate, and you will just need to create an actual .env file. And you need two variables, and they are private keys, which is a bit misleading because it's just one private key, but it can be comma delimited and have multiple, but we're just having one. And the other is the Infura ID. So to get your Infura ID, and we're going to need to create another one a little bit later for IPFS, but for now, this Infura ID relates to the Web3 project that you need to create in Infura.io, and it's free. And once you create the project, you get an ID, and you put this here. Now, your private keys come from when you start up Ganache, which is our local blockchain, and this is also free. So you install Ganache and you open it, and it spins up a local blockchain with I think it's 20 accounts, and they all have 100 fake ETH. So we'll get more into that. But so what we do actually, yeah. So for the private key here, is we take address 0, we click this, and then we copy that private key. So that is literally that there. So, well, in my env it's not there, but yeah. And that is used in the Truffle config. So when you use a Truffle project, you get a Truffle config. And in here, what this does is this has all of the networks that you might want to access on the blockchain to migrate and, call your function on. This is gonna allow you to literally deploy your contract, pretty much. So what we have is Ganache here. We've got a couple. We've got the CLI and the GUI, and then we've got a load of the testnets: Kovan, Rinkeby, Ropstein. Then we have the Ethereum mainnet. We have the Polygon testnet here, Mumbai, and then we have the Polygon mainnet. And what you will see in here is it takes our private keys, which is just one private key, it splits it by the comma delimiting if you had it, but because we don't, it doesn't matter. We just have one, and then it gives it access to the Ethereum node on whichever network you specified. We're just using the default, so we're going to be using this one here. So yeah, that's all good. Then when you come down here at the bottom, this is a cool thing that I learned from DAP University actually. And what it allows you to do is it allows you to restructure your project so you can have the Truffle files inside of your source file. So it just keeps it a bit cleaner for you. And that's all good. So from here now, so just to be clear again, you need two environment variables. One is an Infura ID and one is the private key. And the private key comes from Ganache, or your actual wallet when you want to go on the mainnet, but for testing it comes from here. And one thing to note is don't ever use these account addresses or private keys in production. Never ever do that. Okay, this is strictly for testing. Don't ever deploy to the mainnet using one of these, because they're reused at certain times. They're auto generated, but there's no guarantee that no one else will also get that private key. So yeah, you should never do that. And we can see here it's running on 7545 on the local host. And that's what we've got here for the GUI. So now what we can move on to is the actual contract. So the one in this project that we need to take note of really is the NFT.sol, which is for Solidity, and that is inside source truffle contracts NFT.sol. And what you'll see is it's extending these OpenZeppelin classes, and OpenZeppelin is an open source framework that helps developers create Solidity contracts that are battle tested and been tried by the community and stuff. So what we're doing here is we're extending the ERC 721 class, which is there, and we're calling it NFT. So what we've got here is we've got a lot of different functions, but the main one I guess is the constructor, which is ran as soon as the contract is deployed, and has two arguments here which you can pass in from the front end, but we've just hard coded them here. So one is the token name and the next is the token symbol. So for Ethereum or Ether, this would be Ether and the symbol would be ETH. So that's how that works. So the contract in the boilerplate is a great starting point, but I wouldn't recommend it for production. And one reason for this is I've not included the burn method. And the burn method allows you to destroy any NFTs that you may create by accident. It's 100% good to use in projects on the testnet and to get to grips with blockchain development. But let's just have a look at what functions we have included in here. So we've got mint, which allows you to create an NFT. We've got buy, which allows someone to buy an NFT. And then we've got this validate function here. And what the validate function does is it says, does the NFT exist? Has it not been sold? And is the value that the person's trying to buy it more than or equal to the actual price of the token? I'm not going to go too much more into that because I think, you know, this is kind of like a high level walkthrough of this sort of stuff, and I'd really recommend that you look through the specifications and other more verbose videos focused on Solidity. But this just gives you, you know, high level example of how this works. So what we need to do is we have our contracts and we need to run a couple of functions on them. Not functions, but we want to compile using Truffle, and then we want to migrate using Truffle, right? So the compile function, what this does is this sort of verifies that the contracts are okay to be deployed. So if we run compile, what we'll see is we'll probably see a couple of warnings from the Open Zeppelin library, but they're fine. What we care about is at the top, we're going to get a little tick next to each of them. So while it's saying everything is all good, so that's what the compile function does. And then what we want to do is we want to migrate. Now, one thing on the main nets, you can compile, but you can't overwrite. So once you deploy your contract, it's you can migrate, but you can't overwrite. So once you migrate your contract, which is just deploying it, you can never overwrite it. So, but on the testnet you can. So what we're going to do is, because I've already deployed this, we're just going to run. We're just going to run truffle migrate, and then we've got this flag -- reset. And what that allows us to do is it allows us to redeploy our NFT contract to our local blockchain. So we'll run this, and what we'll see here is it's doing the deployment. And what it does is it's pretty cool because it gives us all of the costs that it's cost us in our fake ETH. And if we go back to Ganache, we will see that gone down. There we go. That's gone down a bit. So it's gone down a little bit because this is the the wallet that we used as sort of the owner of the contract. So now let's actually run the project and have a look. So this is the boilerplate running, and yeah, it's supposed to look a bit disgusting and plain because it's sort of a starting point. So we've deployed the contract, right? And what we can see here is we're getting an error and it's saying cannot read properties of undefined. And the reason for that is on my MetaMask, which helps the browser connect to the blockchain, I've got it set to the Ethereum mainnet, but we haven't deployed the contract to that. We deployed it to Ganache. So now we can see that this amount here matches the amount of this wallet here. So what we do now is if we refresh the browser, then we'll see total supply. There's no error now. We see total supply is 0. So what's that about? Right, so let's have a quick walkthrough of what's going on here. Right, so I'm not going to go on home JSX, and I'm not going to go too much. But one thing to note straight away is this thing where it says import contract from Truffle ABI's NFT.json. So when you migrate or even compile maybe, but definitely when you migrate a contract, a Solidity contract, what it does is it creates an ABI file for it, and that is always in JSON. And what it is it's a massive JSON file, and inside it has all the details of the contract, and it also has all of the networks that it's been deployed to. So the error we were getting was saying that it couldn't get the address, and the reason for that was inside of the JSON file, networks object, and the ID for the mainnet, there was no address because it hadn't been deployed there. Whereas for the Ganache, our local blockchain, it did exist, so it did have the address. Anyway, so what happens here is once the page loads, it runs this load contract function, and there's a lot of commented out code that I'm going to uncomment when we actually come to mint some stuff in a moment. So it runs load contract, and load contract uses Web3.js, Web3 modal to get a connection to the blockchain. And you can see that here. So we connect we create a provider using Web3 modal, and then we use Web3.js, and we pass in that provider, and that allows us to talk and get the current ID that we're on, and then also we pass that in to our ABI that we spoke about to get information such as the address. But this contract variable here is our actual NFT contract, and using this we're able to call the methods on that. Okay, so as you can see here, the total supply method is our contract, which is literally the NFT contract, and it's saying get the total supply, and you always put call on the end, but yeah, get the total supply. These return promises, so you always must use the sync await or some promise library, and then it returns total supply, which is what we see here. Okay, so now we're going on to the minting process, and before you can mint an NFT, and mint just means like create it in your contract on the blockchain. So before we can do that, we have to actually have something to mint. So what we do is we use something called IPFS, and that is the Interplanetary File System. And all that is it's a file sharing website, you could say, that is just has a lot of redundancy. So it kind of ensures that your image will always be available, or your file, or whatever. There's a lot of information on IPFS. It's widely adopted with blockchain developers, so you see a lot of people using it. There are alternatives, but so I won't go into it too much. But anyway, we're going to be using the IPFS HTTP client, and there is another step that you need to do to get this to work. So as we did at the beginning, where you went into Infura and created a project to get the ID, now you need to go into Infura and create another project, but this time it's going to be an IPFS project. And when you do that, you're given a project ID and a project secret. So what you would do is go and do that, come back to the boilerplate and put them here. Then you're set. And all that does is it just allows us to send an authorization header when we do an upload of an image or a file. So what we do is we create a client with the IPFS library. Then what we have is we have this nifty little function here that I've created called upload file to IPFS. And what this does is, in the boilerplate, it accepts a file, but the file is going to be base64 for us. But what I would say is, if you're going into production, you're better off sending an image buffer, just because then it will display in the browser without like an image tag, and it will display in like OpenSea and all this sort of stuff. But base64 is still fine. But yeah, you really want to send an image buffer. So what we do is we're going to pass in base64, and then step one is we're going to upload that file to IPFS using our client. And what happens is, on success, we get returned an object, and inside the object we have something called a path. And the path is just, it's like the unique ID. So we save that in a variable. Then we create a metadata object, and we give it a name, description, and we pass in the URL to the image we just uploaded. Now, a common misconception for NFTs is that the image itself is minted into the contract. However, that's not true. What the regular sort of flow is, you mint your NFT with the URL to your metadata file, and your metadata file is the source of truth for the NFT, and it has everything. And you're not limited to these keys here: image, description, and name. You can extend it, but you do need to have these. And I can show an example actually. If we go to the crypto Ghoulz thing and we go to OpenSea, then this just links to the OpenSea crypto Ghoulz section. So what we can do is we can click on any of these, and when we click on it, we get this here is the the name from the metadata file, and then the description here is what we is the description that I minted in the JSON. So that's that, but you can extend that and have lots more information in there. Anyway, so now what we will do is, let's go back to that function because we weren't quite done. So at the end, what we do is we build this IPFS data object, and all it is really is it's the URL to the image, the URL to the metadata, and then the unique ID for the metadata, the unique ID for the image. And we're just going to, for the purpose of this video, we're just going to dump it straight out. but you might return it to another function and save it in your database and do a lot of other stuff. Before I move on, actually, one thing to note is there is this idea of pinning your items in IPFS, and apparently when you upload an item, so we're doing client.add, which is an upload, when you do that, then you would also want to pin, so it'd be like client.pin, and you pass it the hash, and this would allegedly ensure that your item that you've uploaded is never garbage collected from any of the nodes, so it will have maximum redundancy, but yeah, something to look into, but this will suffice for a test project. So now what we're going to do is we are going to upload a base64 to IPFS and all the other stuff, and we'll see how that works. So what I've done is I've added this is called an IFI statement in JavaScript, and it just means it says a self-invoking function. So if I run this file with node, it will call that function straight away and kick it off. So that's what I'm going to do. But first I need a base64. So one easy way to do that is I've added in the README this URL, and this URL allows us to upload an image, and once it uploads it gives you the base64. So we just take that from here, and then we're going to put that in our IPFS file, and it's going to be really long. So there we go, we've got that. Then what we're going to do is we are going to call this file. We're going to invoke this function. So let's go node, where are we? We're in source, utils, IPFS. So I'm going to call this, and it's going to be pretty quick, and it's going to spit back the URLs that we care about. So what we've got here is we've got the image URL and the metadata URL. So if I open the metadata URL, what we're going to see is it's everything that we had in our metadata object, the boilerplate, well, the name, the description, and the image. And if we open this image URL here, what we're going to see is we're going to see the base64 string that we have uploaded. So now what we can do is we can go into home.jsx, and we can uncomment this function that's here, and we can put in, let's go back to here, we can put in our ID, which is also of note, which is also here, image hash. Actually, let's take it from here, makes more sense. So this is our console, and we're just taking out our image hash CID, which was returned when we ran that function. So if we put that there, and then we rerun this, so this is quite literally using the that's just, yeah, it's just a picture of Michael Jackson, but that's just quite literally using our CID that we got here, which was returned in this IPFS function. But yeah, so that's all this block comment does here, is it allows you to pass in an ID, which would be your image hash CID. You put this here, and then you will be able to retrieve the image from that URL. And then what we're doing is just updating some state here of image path, and if we follow that down, we'll see it's just saying, does it exist? And if it does, plonk it out onto the screen. Again, it's real sort of stripped back code. There's no, it's like no frills almost. So if we refresh that, that will go back away. So that's how that will be left. And I'll also take that out. So that's ready for when any of you guys try that. So now, right, so now what we want to do is we want to do some minting, don't we? So let's now keep a note of this. I'll keep this open. And what we need to do is we need to go to this file called mint.js. And what we've got here is another function that we will call, but we will call this using Truffle. And what we're going to do is, you see we've got IPFS CID. This is where we put our URL to the metadata, which is this one here. And then what we've got is the cost of the NFT, and this is in way, so it's 18 decimal places. So 1 followed by that amount of decimal places is 1 ETH. But yeah, that doesn't matter for now. But so what we're going to do is let's take this, which is our URL. We'll put that there. So then that'll be passed in here into the mint function, and this is using Truffle, so it's able to what it's doing is it's saying const NFT artifacts.require NFT means get me the contract named NFT. Then what it does, because it's using Truffle, it can say get me the deployed version of this, or confirm that it's deployed. But really it's saying put that contract into this variable and then I can call functions on it. So what we do is we get that. If it's a success, then we come down and we can call any of the methods in the contract. So we're going to call nft.mint, and we're going to pass it the two arguments of the URL and the cost. And if we look in here at the mint function, we will see token URI, which is the metadata URI, and then the price. And the price is a uint256, which means an unsigned integer, which means it has to be positive. It can't be a negative number. Cool. So that's how we do that. So now let's run the mint. So to run the mint, we're going to go this command here, which is, I've got space at the front of that, I think. So it's let's get to the end. It's npx truffle exec, and then the path to this file relative to where you are. So now, one thing to note before I run that is let's go to the boilerplate. Let's refresh the page. And what we will see is our total supply is 0. And total supply, as we spoke about earlier, is the total amount of NFTs that have been minted for this instance of the deployed contract. So, and I say this instance because when you're on the testnet, you can overwrite them. So, if we do a migrate reset, then the total supply goes back down to 0. It sort of nukes the whole thing. So anyway, so now let's mint that, and hopefully we don't get an error. We shouldn't. It should just say minted your NFT. So you see it used the Ganache network and it minted the NFT. So now let's refresh this page and we should see total supply of 1. And we do. So excellent. So now what we can do is we can run some more functions on that using Web3 JS. So let's go to home.jsx. And what we're going to do is, you see I've got this, it says uncomment this block once you have minted an NFT. So we'll uncomment that, we'll save it. And the token ID of 1, because it's not 0 indexed, it's like an array, it starts at 1. So that's the first token ID. And what we're going to do is I'm going to refresh the page in a moment. You're going to see a lot of console logs. So let's do that. And this could be, if you've minted 2,000 tokens, this could be any number of a valid token. So you could be, token ID of 1,999. But for us, we've only done 1, so we're going to do that. So now, actually, you could already see the logs there. So we've got the URI. So this is the URI to the metadata. So let's open that. And, oh, sorry, I've put the wrong... Sorry, I put the wrong thing in there. There we go. So there we go. That's the path to what we minted. So then we have the owner. And this is just the owner of the NFT. And then we've got... The owner is going to be the contract address. So if we go, I bet we won't still have the log from that, but that address will be the address of the actual contract, because the NFT belongs to the contract. So then we've got sold is false because it's just been minted, and then we've got the price, which we set when we minted the thing. Thanks very much for watching or being part of this process, or reading the blogs, or downloading and forking the boilerplate and having a go on your own. Hope this really helps you out. Thanks a lot.